Okay, good afternoon, everyone. I will be talking about this long title that we just mentioned, which is essentially a device developed within our group, within the medical optics group of ICFO Spain. Device was developed by my colleague Andres, who's also not here today. So if you have any more detailed questions, I would direct you to his email and to verify with him. I will try to answer if there are any other questions that I'm aware of. Essentially, we'll be talking about device for medical care, developed in a collaboration with the University of Texas Southwestern, the group of Professor David Bush, for the COVID-19 patients and the measurements on endothelial function, for which I would like to thank Jana for giving us the introduction on importance and the methods, and Kevin as well for his talk, which was related to it. Essentially, what was our idea? Within our group, we previously developed a device for the VASCOID project, which will be mentioned in the afternoon talk by Turgut, which gave us the insight in the oxygen saturation and blood flow using the time domain mNIRS and the DCS. And then furthermore, we also developed SCOS for measuring the blood flow. And then we thought that whether at this point would be possible to recreate the VASCOID device in a version which would implement SCOS as the main driving force instead of DCS, and whether we could, by using SCOS instead of DCS, drop the size and the cost of the original device. Again, I will thank Maria for giving us the intro on SCOS, DCS, and all the differences and benefits of one and another. We essentially use Speckle contrast optical spectroscopy SCOS to extract the information on the blood flow by measuring, by shining continuous wave laser and measuring with the CMOS camera, and then doing some statistics. And we combine it for now with the SRS in order to extract the information on the oxygenation. In long term, the idea for us would be to implement the information from different wavelengths into a different kind of algorithm, which would allow us to have measurements reasonably faster and within the same algorithm instead of using two at the time, for a device which currently looks like this. So this is the Brigio device developed by Andres, which is essentially, I would call it a smaller, younger sibling of the VASCOID device. It's composed of 2 detectors, 2 CMOS cameras, and 6 lasers at 3 different, three different wavelengths, 2 lasers each wavelength, which give us a total of 4 different source detector separations. The device itself has all the other parameters incorporated inside, such as the arm cuff, the pulse oximeter, all the emergency buttons, etc. And as mentioned, it's intended use in the ICU. The cost of this device compared to VASCOID, now that we change all the expensive detectors and everything, drops by the factor of 10. So from 50K VASCOID device, we go down to approximately 5K Brio device. And this is how the current graphical user interface looks like. It allows us 2 modes. First mode being the master mode, which is pretty much used by us, where we can set all the parameters related to the camera and the acquisition, etc. And then we have this viewer mode, which is intended for the clinicians, for the doctors, for them to be able to see all the relevant parameters for them. Usually we leave this first master mode locked so that information cannot be, the settings cannot be changed, but information can be accessible. And it's important to say here that everything within this software is automatized. So we have all the cuffs, all the protocols, everything within a single click, which allows us to just do the measurement right away. Another important aspect is the probe. The probe itself has all the components integrated inside. So we have a diode lasers right there with the heat sinks. We have the camera fibers. And we also have the capacitive sensor to make sure that to improve the signal quality and to make sure that the attachment of the probe is done right. You have the example picture over here with the pulse oximeter and the probe connected from the device. And another important issue when putting lasers directly on the skin is whether we have all the safety regulated. So we also did the tests of the probe temperature to make sure that it doesn't exceed certain standard, the ISO standard. As you can see, we're fairly away from it, although there's slight heating from the device, which is usually, 2 to 3 degrees in general case. One sample of the data that we extract directly from the device, the left one being the kappa square, from which we later fit for the blood flow. And for all the different source detector separations at 785, you can clearly see that we can, if we zoom in these measurements, we will see the heart rate peak visible, the trace of the heart rate peak, and then the SNR is reasonably high, given that the SCOS has the advantage over the DCS in those terms, given the higher number of the detectors at a single measurement. One example of the measurement that we've seen plenty of times during this conference, the vascular occlusion, where we can extract the parameters for both the oxygenation and the blood flow related to the baseline, the slopes, oxygenation, deoxygenation, the hyperemic peak, and the release values after certain resting time. As I said, the initial intended use of this device is related to the COVID patients and measurements on the brachioradius muscles. So Andreas, colleague of mine, performed all the basic tests, and at this point, he's doing the clinical validation of the device with the intention of having over 100 subjects. The measurements are done in the US at the UT Southwestern at this point. This is our group, and thank you for listening to this talk. 10 minutes? Yeah.
Perfect timing. So there is time for questions. Are there questions from the audience? Yeah.
So in comparison to this measurement with other measurements, say MRI, how they correlate?
In principle, the validation was done with DCS, which itself has been validated by other methods. So I'm not sure if I included that in the graphs, but we have the validation of this measurement versus DCS in a couple of different protocols, including the vascular occlusion.
Any other question?
I'm not sure I misunderstood Maria's talk. Maria said that she couldn't get work. Is that right?
During motion.
During motion, okay.
If we're considering motion, we also have the problems with the motion artifacts in both DCS and SCOS, and we're working on resolving that at this point. But on a general scale, they're perfectly fine.
Yeah, I have a follow-up question. Have you tried on different muscles with different type of occlusions, durations?
Okay, so this is interesting. Yes, and I think the poster in the afternoon that will be mentioned with the Rhythmian device that Turgut will present deals with the occlusion on the leg. So we have the comparison of leg versus arm in that case. And also speaking of the arm occlusions, we not only observed one muscle, which is the brachioradialis for the COVID-19 patients because of endothelial function, but we also have some sports studies that we did related to the flexor digitorum profundus and superficialis on the climbing exercise.
Okay.
So we have some references for that as well.
Okay, thanks so much. I think we can go on.
Thank you.